let's review some concepts for your competency exam. So on this first particular problem, we are being asked to take what is known as a cube root of all of those numbers. So let's start with a 64 first. Now, what we're thinking with the 64 is, do we have a number that when we multiply it by itself 3 different times, we would get 64? And so if we do, then we've got a cube root. If we don't, we've got to look for other factors. So you could factor it down into prime factors, or what I typically do is I just start trying to think of perfect cubes. So, of course, 1 cubed does us no good. That's just 1. 2 cubed would be 8, and 8 is a factor of 64, but let's just keep going. 3 cubed would be 27. 4 cubed would be 64. And so right there, we see that we do have a perfect cube. If we didn't, then we could go back and work with at least a factor that had a perfect cube. So in this case, the cube root of the 64 gives us a 4. Now, when you are trying to take a cube root of variables raised to powers, what happens is you take their power and you divide it by the root. So if I have r to the 15th and I'm taking the cube root, that will leave me with r to the 5th power. And if I have s to the 18th power and I'm taking the cube root, 18 divided by 3 will leave me s to the 6th power, just like that. So that would be my simplified expression. Okay, so in the next problem, we're being asked to simplify, and we have to write the answer using positive exponents only. Okay, so first of all, this power that is outside the parentheses has to apply to all terms. So we're going to have a 5 raised to the negative 4th power. We're going to have an x, and it will be raised to the negative 28th. So the rule of exponents says that when you have a power of some term raised to another power, you multiply. Okay? And then on the y, it's going to be raised to the negative 4th. And then notice that this second set of parentheses doesn't have a power out there, so we'll just say we've got the 7, we've got x to the 1st, and we have y to the 5th. Now, as we go to simplify this, because they said use positive exponents only, notice that the 5 to the 4th is going to have to end up going to the bottom. So when you have a negative power, the way we get rid of the negative power is we move that term. If it's in the top of a fraction, we move it into the bottom. If it were in the bottom, we'd bring it to the top. So we'll move it on the bottom. Notice the 7 just stays on top. Okay, so then with our x's, when we have an x to the negative 28th and it's multiplied by what's understood to be x to the 1st, you actually add powers in this case. So x to the negative 28th times x to the 1st would leave me with an x to the negative 27th, because when you add negative 28 plus 1, you get negative 27. We'll deal with moving that in just a minute. And then finally, when we look at the y's, you have a y to the negative 4th times a y to the 5th. So again, you're going to add their powers, and that will leave you with y to the 1st. So to finish simplifying this, we have our 7 on the bottom. If I take 5 raised to the 4th power, I end up with 625. And because that x has a negative power, then we need to move it to the bottom of the fraction. And once we do, the power is positive. Notice the y already has a positive power, so it stays on top. And you don't have to show powers of 1. So that would be my simplified final answer. Okay, with this next problem, we are going to multiply using the rule for finding the product of the sum and difference of 2 terms. So I like to think of FOIL, where you take first term times first term. So 2 times 2 would be 4. And then the O in FOIL, so F-O-I-L, the O stands for outside. So 2 times y to the 6th would give me 2y to the 6th. And then the I is inside. So negative y to the 6th times 2 would give me negative 2y to the 6th. And then the L in FOIL stands for last. So negative y to the 6th times positive y to the 6th is going to give me a negative y to the 12th. So remember, when you're multiplying with common bases, you're going to add their powers. Okay, so if I go ahead and simplify this, you'll notice these two terms zero each other out. So my final answer here is just a 4 minus y to the 12th power. Okay, on this next one, we're simplifying a rational expression, and then we're going to talk about excluded values of your domain. So in order to simplify, you need to factor. I notice on top, these two terms have a factor of 4 in common. When I factor that out, I'm left with x minus 3. And then on bottom, if I try to factor this trinomial, the x squared I can break apart as x times x. If I think about factors of positive 9, that will add up to negative 6 in the middle. I'm going to take a negative 3 times negative 3. And so now what happens is, because you have a factor of x minus 3 on both top and bottom, that whole factor cancels each other out. So we are left with 4 on top, and we are left with just a single x minus 3 on bottom. So that's our simplified answer. Now, when we talk about exclusions from your domain, what we know with fractions is we cannot have a 0 in the bottom of a fraction. So if you have an expression involving x on bottom, you're going to have to say that expression cannot equal 0 and figure out which x gets excluded. So if I get x by itself, I'm simply adding 3 on both sides. And so in this case, what I'm saying is that my exclusion would be x cannot equal positive 3. Finally, when you're asked to factor a trinomial such as this, I typically just use a trial and error method. And so when you're thinking about breaking up, first of all, the 6x squared, you've got two possibilities. You could have a 6x and a 1x, or you could have a 3x and a 2x. And so that's why I call it trial and error, because we don't know up front which one's going to work. All right, so next thing we look at are factors of positive 10, and we need them to add up to negative 19 in the middle. Now, the only way you're going to get a positive constant that adds up to a negative in the middle is if both signs are a negative. Okay, so let's start with trying factors of, or two factors of our 10. So if we just did 10 and 1 like this. So in this case, you would get a negative 10x and a negative 6x, and that does not give me my middle term. So we say, okay, that didn't work. Go back. Two more factors of 10 would be 2 and 5. And if we do this, we get a minus 2x and we get a minus 30x. So that did not work. And then we can switch them around, or you could have switched them around to begin with. So you could put the 10 here and the 1, and that's going to give you 1x and negative 60, so that's way off. Or you can do the 5 here and the 2 here, and notice in that case you're going to get a negative 12x on the outside and a negative 5x on the inside, so that still didn't work. So then we say, okay, let's go down here and try. So again, trying our factors of 10 and 1, I get a negative 20 and a negative 3, so that's not negative 19. If I switch them around, you're going to get a negative 2 and a negative 30, so that's not going to work. So then I come with my factors of 5 and 2. So if I put a 5 here and a 2 there, I get a negative 10x and a negative 6x, so that's only 16. And then finally, if I switch those around, put my 2 here and my 5, I get a negative 15x and I get a negative 4x. And finally, I didn't plan that on purpose for it to be the last one to work, but finally we see that that adds up to a negative 19x. So my correct factors here are 3x minus 2 times 2x minus 5.